Hello, in this video I'm going to look at equations of circles. So equations of circles starts by looking at a center point. Now in either case, like if we had a center point like right here, then we would need to look at the distance from the center to any point on the graph of the circle. So in this case we have that there's a center at 3, 3. And it looks like if we count from 3, 0, that we have that the distance from 3, 0 to 6, 3 relative to the x-axis is 3 units. So in that case, that would tell us that we have that the r for this equation is equal to 3. But in any case, we also have that the center accordingly is just 3, 3. Now, what does that mean in terms of like the equation of the circle? Well, to understand that, then basically we would need to know the equation of a circle, right? So let's just suppose that we have that this is the center, but we give it a name and call it like h comma k. This point right here is going to be the ordered pair x comma y. Now, how would I find the distance from the center to here if in fact the distance is given by r? Well, in that case we can actually just use the distance formula, which in this sense says that the distance from P to Q is equal to the square root of, well, we say that it's y2 minus y1 squared plus x2 minus x1, and that's going to be squared. Okay, so in any case, this is going to be our formula that we would use. And let's go ahead and just move this so that we have it. Okay, so this is going to be our equation that we're going to use, right? Okay, so, and we'll just move that. And, okay, I think that's good enough. Now, in any case, how are we going to find this? So, okay, so if we labeled these as P and Q, for example. So like if we labeled these as P and this as Q, it would be actually the same thing because, we would have that, okay, well, we just need to find the distance, which is r, and that's going to be the square root of. So how do we find it? Well, if we take the distance from y to k, it's just y minus k squared. Plus, from h to x, it's going to be x minus h, and that's going to be squared. Now, notice that basically what this does is it gives us an equation that determines the radius in either case. Because we have that if we go ahead and we square both sides, we get that this would be x minus h to the second power plus y minus k to the second power equals to r squared. So we have our equation of our circle, and what we'll do is we'll just go ahead and say that from this equation we have that the center is given by h comma k, and we have that the radius is just going to be r in either case. Now, the thing, though, that we should realize is that the radius is actually a positive number in either case. So we can assume that for sure that this is definitely a positive number for circles. Now, if in fact we had that the origin was our center, so like if we had that the center was the origin, which in this case that would be right here, at 0, 0, then that would give us that you have x minus 0 squared plus y minus 0 squared equals to r squared. But doesn't that give you x squared plus y squared equals to r squared? Which in actuality, like if we wanted to draw a picture, then it would be, it would be a circle that's centered at the origin in either case. Like you'd have something like this, and then you would just label appropriately as, you know, like you'd have that's going to be r, that's negative r, that's negative r, and that's r. Okay, so we have that this would be our circle that's centered at the origin in either case. Let's go ahead and get rid of that for now. Oh, yeah, r squared. Okay, so what we can do is just maybe look at a couple of examples. So like if we have that the center is the origin, but we have that the radius is equal to 2, then in either case we would have that would be just x squared plus y squared equals to 4. Now if we wanted to draw this in the x and y plane, well, we could probably just draw a circle and then just go ahead and just draw the axes as needed, and then we'll just label these as negative 2, 2, well, it's negative 2, right? 2, and then 2. And then you would just label, again, like that's your x, and this is our y-axis, right? So we have our graph of our equation. Now, you can graph this in the x and y plane by using the graphing calculator, but unfortunately to do so, you would have to solve for y. How do I do that? Well, how I do that is by taking x squared and subtracting it, where I get 4 minus x squared, and then I would take the square root, and then that would give me that y equals to plus or minus the square root of 4 minus x squared. So what do we do with that? We would actually plug in the top half of the circle, 4 minus x squared raised to the 1/2, and then you would plug in y2 equals to the square root of 4 minus x squared, but there would be a negative sign in front, okay? Now, if I wanted to, let's say, for example, just find a circle that has, you know, like coordinates where you have that the radius might be given and also the center. So like if we had that, you know, the center similarly was 3, 4, and then we had that the r was equal to 5, then how would you get the equation of the circle? You would get it by saying x minus 3 to the second power plus y minus 4 to the second power equals to 5 squared, which in this case would be 25. So we have that would be x minus 3 squared plus y minus 4 to the second power equals to 25. That would be the equation of the circle in either case. Like for, you know, like if we wanted to know like what was the center and radius form actually of the equation. Now, we do have that, you know, we could probably go through the process of finding out like how do we graph this equation in our graphing calculator, but you know what you'll find is that the process of going from here to y1, y2, you're going to find is a bit more challenging, because basically you're going to find that the equation y, if you solve for it, it's going to be plus or minus the square root of 25 minus x minus 3 to the second power, but you would have to not forget to add 4. Okay. Now in this case you can do this where you plug this into your calculator and you will find, you know, the graph of that specific equation. Now, if I wanted to though, I could actually find the equation of a circle by going to Desmos, where maybe I could probably input this into you know, the calculator. So like let's try to do this. Okay. Okay, so we'll do this where we'll just Okay. Now here I have a graphing calculator already programmed where all I need to do is just give it the center. So for example, we said that we're going to do 3 comma 4. Okay, so 3 comma 4 is right there. And then the radius we said was 5. So notice that you have these points. You have the center, you have the one that's to the left, to the right, up, and down. So if we were going to do this from scratch, you know that you would go down 5 units, which is -1, up 5 units, which is 9, and then left and right respectively. So like 5 minus 3, -2, and then similarly 3 plus 5, 8 comma 4. So we see that this is actually going to give us a circle, right, in the x and y plane, where the distance is always the same in actuality. Okay, so this is actually pretty convenient in either case as it relates to finding the graph of this equation, right? And yeah, it is actually that simple where you would just type this equation into Desmos and then it would give you the graph immediately. Now, we do have, though, that when we look at the form of a circle or the equation of a circle, like x minus h to the second power plus y minus k to the second power equals to r squared, we do have that if we were to expand this, by expansion I mean foiling, that if we have x squared plus y squared plus cx plus dy plus e, that this equals to 0, then in actuality we have that this is what we call the general form of the circle. But there is a bit of a problem. The problem is that if I go ahead and I complete the square for this going from here to there by completing the square, then what that means is that r squared could be either positive, it could be equal to 0, but it also could be that it's less than 0, meaning that basically we have these 3 cases. What are the 3 cases? Well, the 3 cases are that you could have a circle, you could have a point, and then you could have what we'll say is a non-existent circle. So what we'll do is look at the general form of a circle, and then we'll try to see if we can, go from one or the other in either case. So let's say that we have x squared plus 4x minus, well actually we'll do plus, right? Plus y squared minus 8y minus 44, and that equals to 0. Now, what I'm going to do next is actually to complete the square. How do I do that? I take x squared plus 4x, I take half of 4, and I square it. I take y squared minus 8y, and I add -4. Actually, it's -8, isn't it? Yeah. So -8 divided by 2 squared equals to, well, I'm going to add the 44 to this side, but I'm also going to add everything else that we squared, right? So notice that 4 divided by 2 is 2 squared, so that's going to be plus 4. And then notice that -8 divided by 2 is -4, and that's going to be 16. So plus 16. So we'll go ahead and simplify this even further, where we'll say that we have x squared plus 4x plus 4 plus y squared minus 8y plus 16 equals to 64. Now, what should we do next? Well, what we should do next is to go ahead and just combine these terms, because these represent a perfect square trinomial, and this is a perfect square trinomial, and this is just 8 to the second power. So this is going to give us x plus 2 to the second power plus y minus, so what is that? Minus 4 to the second power equals to 8 squared. So we have our solution, don't we? We have that the equation is indeed a circle, but what else can we say about it? We can say that the center is at the ordered pair -2, 4, and we have that the radius, what is the radius? The radius is just 8 in either case. So we could probably, say that if we wanted to check and see like whether an equation is a circle or not, then we could probably say, like try the equation x squared plus y squared plus 2x minus 6y plus 14 is equal to 0. Once you rewrite this, you'll probably figure out that the answer is actually no. This does not define a equation of a circle at all in either case. You'll just say that the graph is non-existent. Okay. Now, if, for example, that I wanted to know a equation of a circle, and let's say that we did that with using 2 points, okay? So let's say that we have a circle, okay? And we'll just draw, like maybe a big circle and see, that's actually not a circle, right? Let's just do it like that. Okay. So note that if I was to draw a line right through here, that essentially I have that, you have points A and you have B, right? But at the center, you have C. Okay, but how do we define the length of the endpoint? Well, it's actually the diameter, right? So it's the diameter of which the diameter relative to the length from the center to any point is 2 times the radius. Okay, so that means that basically we have that the radius is equal to the diameter divided by 2, but that's given 2 sets of endpoints in actuality. So why don't we use that we have a circle? So we have a circle with the endpoint 5, 4, and we have another one with -3, -2. Okay, so why don't we find the distance then? Well, the distance, if this defines the endpoints with diameter, then we can actually just say immediately that we have r is equal to, okay, so we're going to take the square root of -2, and we'll do it like this. How about -2 minus 4 squared plus -3 minus 5 squared? And what do we need to do? Well, we need to divide that by 2, right? So that's divided by 2. Now, accordingly, that's going to be 36, right? Because you have -2 minus 4 is -6, and you square that, you get 36. -3 minus 5, that's -8, but when you square that, you get 64, and this is all divided by 2. Okay, but what does that mean? That means that you end up with the square root of 100, and that's divided by 2. What's the square root of 100? It's 10, but divided by 2, that gives you 5. So we find that the radius of the circle is actually going to be 5 units. Now, actually though, we're not finished because we need actually to find the center. So in finding the center, we need to work with the 2 endpoints, right? So the center is going to be basically the midpoint. So the midpoint is essentially just going to be 5 plus -3 divided by 2, comma, 4 plus -2 divided by 2. But notice that that gives you the ordered pair 1, comma 1. So what does that mean? That means that you're going to end up with a circle that's centered at 1, 1, so x minus 1 squared, plus y minus 1 squared is equal to, well, you're going to do 5 squared, right? So in that case, we have our circle, right? We have our circle. And, you know, like if we want to graph this in the x and y plane, then we can do that too by going to here. And what do we need to do? We just need to change that to 1. We need to change this to also 1. Okay, so let's get that 1. Okay, there you go. And the radius is actually the same, is it not? So we have that this is our circle centered at 1, 1, and we had the endpoints that were given, right? The 5 comma, let's see, what was our endpoints? 5 comma 4 and -3 comma -2. Notice that it's not technically labeled on here, and that's because of the fact that we chose these points along here and just, you know, we had 5 comma 4. So 5 comma 4 is like roughly right about there, so 5, 4. And then we had that -3 comma -2 is right there. But see like how the center is exactly 1, 1 by using the midpoint formula. Now, it would be a little bit challenging to write this in terms of x so that you could plug this into your calculator, but it's not impossible. So, you know, you can try using, you know, the calculator in either case if you'd like to. But, you know, it's best to just go ahead and plot the important points to the left of 1, 1 by how many units? 5. To the right by 5, up by 5, and down by 5. What do? You connect the dots. Once you do that, you end up with a circle centered at 1, 1 with radius 5. Okay, now in either case though, the other thing that we can do is, like, if we were to put it in general form, then of course, yeah, we know that it's already a circle, is it not? Now, if we, let's see. Now, similarly, we have that if we had that the radius was 0, then it would just be like a point in space in actuality, but that would mean that the there was no diameter in either case, so we got to be careful with that, actually. Now, if you want a better understanding of, like, you know, relative to the graph in standard form, what you could probably do is just say that, well, what did the 1 do? It moved it to the right by 1 unit. What did the k do? It shifted the graph up by 1 unit. Of course, we have that the r was 5, okay? So what we can say is that, you know, when we look over here and we change the h, notice that it's moving left and right, essentially. So we have that that moves it to the left and to the right, but then we have that, what does the k do? It moves it up. So see like how I can actually move this up. But notice that if I shift the graph of r, what does it do? It makes it bigger, okay? So, you know, you could think of this in terms of, like, you know, your cell phone coverage, or in some cases when you lose your cell phone, you're trying to find it, right? Or you're trying to find the nearest pizza delivery, in either case, from where you live or where you are, right? Now, notice that if I make it smaller, then what am I doing? I'm narrowing down basically the area that's closest to the center. You could think about this in terms of, like, okay, well, what if I want to sell something or buy something, and in this case, I want to limit it to less than a specific amount, like maybe like a mile from where I am at, for instance. And this would be our circle, right? But notice that if I go ahead and I make this equivalent, like I make this equivalent to 4, so like I have the equation x minus 4 squared plus y minus 4 squared equals to 4 squared. Notice that this circle is tangent to the y-axis in either case. But similarly, I could actually change that. I could actually change this to where I move it up by 4 units also. I might have said the wrong formula. It was x minus 4 squared plus y squared equals to 4 squared. Now it's actually x minus 4 squared plus y minus 4 squared equals to 4 squared. Because now, notice that it's actually now tangent to this point at the y-axis and tangent at this point at the x-axis. This is actually kind of cool when you think about it, because then I could have like 4 different circles that are tangent, and you know, I could look at that too. Like it's almost like I have like a nice little symbol in either case, if I was to do that. Or what if I was to only consider just the curves and where they intersect? Then I would end up with what is called a hypercycloid in either case. And that's actually kind of interesting when we look at equations like that. It kind of looks like a star in either case. Like if I had another one over here, and another one here, and another one here, then in that case I would have kind of like a star in either case. But for us, we're just using circles, right? So I hope that this video helps you and that it gives you some insight to what we could probably use circles in terms of real-world applications, which include actually, interestingly enough, considering earthquakes. You know, like if I had that the Richter scale was able to locate 3 locations for an earthquake intensity, then in that case we can actually look at what was the epicenter of the earthquake, thus determining the origin of the earthquake using circles.